Okay, so for this next word problem, again, we have our rate of work formula, and we just need to make sure we're labeling stuff. So working together, Tanner and Joel can grade their students' projects in 2 hours. So they just told us what capital T is, all right? Working alone, so again, we're talking individual times, it takes Tanner 2 hours longer than it would take Joel to grade projects. So looking at that language, how about I let X be the time for Joel to do the grading, and since Tanner does it 2 hours longer, that means that X plus 2 is the time for Tanner. Alright, so that's what that language interprets. So if I let X be what Joel's time is, since Tanner's working 2 hours longer, that means Tanner's going to take that time and add 2 to it. So I have my individual time. So formula, 1 over my individual time plus 1 over my individual time equals 1 over the time that it takes us to do the job together. And so there's your setup. Alright, so next we go through how do we solve an equation with fractions in it. We clear them. Looking at all my denominators, we basically have to multiply them all together to get my LCD. Now that I've got that, I'll multiply both sides by that LCD. And that's going to clear the fractions. So on this side, as I distribute, the x's will cancel, and we're left with x2 times x plus 2. For the next one, the x plus 2's will cancel, leaving us with 2x. Over here, the 2's divide out, leaving us with x times x plus 2. So fractions are cleared. Let's see what happens, right? So if we multiply things out and combine like terms, what we see is we have a quadratic equation. So as we constantly have been seeing, what happens next, right, is I set one side equal to 0, and there's basically our equation. So x squared minus 2x minus 4, right, would be our equation. Right, and so what I'd hope for is that this factors, and it looks like it doesn't, and so we're going to basically have to solve this using some other items. Again, we have the quadratic formula, or we have completing the square. Right, and what I'm going to do for practice, since that's a nice even number, I'm going to complete the square on it. So let me bring this back over here. So we get x squared minus 2x. I'm going to push that 4 over to the other side. Right, and then I'm going to take half of that negative 2. I'm going to square it, and that's the little piece that I need to add to get things going. This now factors as x minus 1 squared, and that's 5. Using my square root property, I get those two answers. So x minus 1 is plus or minus the square root of 5. So x is 1 plus or minus the square root of 5. So now we have to kind of make sense, right? There's either 1 plus the square root of 5, or x is 1 minus the square root of 5. And I'm thinking this one's extraneous because the square root of 5 is, at least 2.1. So if I take 1 and I minus, 2.1, that's going to be a negative number. And we're talking about time. So that makes no sense. So this one right there makes the most sense. So Joel, looks like it took him 1 plus the square root of 5, right, hours to do the job. That would be the exact answer. Of course, we can go to our calculator to get an approximation, which I bet my math lab is going to make us do, but I'll do that here in a moment. To get the other answer, all I got to do is take this answer and add 2 to it. So I'm going to take 1 plus the square root of 5 and add 2 to it. So Tanner's time is 3 plus the square root of 5. Right? So again, those are the exact answers. If the textbook is asking for exact answers, that's what I type in. But I bet they're going to want some approximation, so let's go ahead and do that. So this is my cell phone, if that's okay. So we got 1 plus, and we got the square root of 5. So it looks like it's giving me here 3.23. How about I go out to 4 decimals? Looks like 61 seconds. All right, or excuse me, hours. And as far as Tanner is concerned, let me clear that out. That'd be 3 plus the square root of 5. And it looks like Tanner's time is 5.23 and 61 hours. All right, so whatever they want. So that's basically the approximation that I'm getting as opposed to the exact answer, right? It just kind of depends on what what Pearson wants. So just make sure you're following the directions. If you have questions about it, let's hammer it through together in class when you ask questions, and we'll try to figure it out together, because we do know that Pearson can be extremely picky. But overall, right, there's basically another quadratic application. It's basically an old idea of our rate of work problem, but as we set it up and we solve, all that work leads to a quadratic, which is why we're seeing it here in 11.4. Right, so that pretty much wraps up our discussion of 11.4. Right, let's move on and do some bigger things and some sections coming soon, and I'll talk to you guys later.